So congratulations on staying with us this far. Still so much more to go, but we have a next vocabulary word. We've talked about this word many times. It's time for us to actually define it and make notes. Ideally, you're taking notes the entire way through. You're practicing the refrigeration cycle and you have that memorized by this point. Ideally, you're studying all of the vocabulary words, but if you haven't, this is the word that you really need to know. And it is called saturation. Now, my spelling's atrocious, so just bear with me. Saturation, I've talked about this many times, we've hit it many times. This is the point that's important. Saturation means many things, but number one, the most important thing that you need to know about saturation. If I say saturation, this needs to, bam, instantly pop in your head. It needs to be a knee-jerk reaction. Saturation, PSIG, converted to temperature. And that's called a saturated temperature. Pressure converted temperature, PSIG converted temperature, pressure converted temperature. If I say saturation, immediately pressure converted temperature, just instantaneously. If I'm talking about saturation, PSIG converted temperature, okay, that needs to be, must happen in your mind. So we took a pressure reading, and the pressures are relevant to me. We took a pressure reading, we're going to convert that to a saturated temperature, PSIG converted temperature, pressure converted to a saturated temperature. Our temperature pressure chart, we're going to talk about many other ways to do this that are way better than this, but we need to know this for the test. Pressure converts to a temperature. That is saturation temperature. So outside I have a saturation temperature, and also we have inside, we're going to have another saturated temperature. Pressure converted temperature. PSIG converted temperature. Pressure converted temperature. However you want to say it. Pressure converted temperature, PSIG converted temperature. Know that this converts to a temperature. Could care less about pressure. I need that temperature. That temperature is essential. In HVAC, we deal with a lot with temperatures and heat. So I don't care about the pressure. I need temperature. It's number one, most important thing. I'm going to put a number one here. Most important thing, have that in your head, locked in. All right, so it also means several other things. These aren't in any necessarily, it also means several other things. These aren't in any particular order, but it's good to know them, to understand what's going on. So pressure converted temperature is number one. Let's say in any particular order, we're just going to number them. Number two, change of state, latent heat. Change of state, please write it down with me. Latent heat. Some of the other videos, we talked how the importance of change of state was. It is so important to understand how there's massive amounts of BTU. It's very, very powerful. So here we have a change of state in the evaporator coil. That is latent heat that's going on there. Saturation also means change of state, latent heat. Here we also have latent heat happening again. Saturation, change of state, latent heat. It is very important. So change of state, latent heat. All of that also means saturation. It's interchangeable. Interchangeable word. Right, another word we're going to have. It's where liquid and vapor both exist. Or you could put coexist, however you prefer it, but there's liquid and vapor together. So if we talk about a refrigerant tank, and as long as there's liquid and there's vapor in the tank, then it will match a temperature pressure chart. As long as I have liquid and vapor, if I know the pressure of the tank, I can tell you the temperature of this tank. If I know the temperature of this tank, I can tell you the pressure of this tank, because there's liquid and vapor together at the same time. Because anytime there's liquid and vapor, you're going to be at saturation. Here in my evaporator coil, there's liquid and vapor coming out of the metering device, 75% liquid, 25% vapor flash gas. Because there's liquid and vapor coming out of that metering device, it's immediately, boom, instantly at saturation, PSIG converted temperature. That saturation all the way through most of the evaporator coil, changing state from a liquid to a vapor. After it's all vapor, we can do other stuff, but saturation are both together. Outside, we also have a saturation. We're going to have it to where liquid and vapor exist. We're going to change state from a vapor to a liquid. If we start out at all vapor, here we're half and half, here we're all liquid. That change of state, there's liquid and there's vapor, it's for sure going to be saturation. Very, very important word, means several things. Let's talk about another one, saturation. It also means boiling and condensing. Another one we're going to add to the list, number 4 down here, and we're going to put boiling and evaporation. Over here, the refrigerant's literally boiling, just like we saw the water in a vacuum chamber. It's literally boiling. It's that same color. It's clear. It's boiling, violently boiling, changing state from that liquid to vapor. That is what's happening. Also evaporation. That's happening inside the evaporator coil. It's absorbing heat. That is saturation. And also, we'll put on here number 5, condensing. So condensing is the opposite. The refrigerant is condensing. It's changing state from vapor to liquid. It is saturation through the majority of that condensing coil. Saturation is a key word. We cannot change saturation until all of the vapor is gone or all the liquid is gone. As long as I have liquid and vapor, we're at saturation. Now remember, PSIG, even though I'm getting that reading outside at the outdoor unit, it's connected to the suction line, and this pressure converts to a saturated temperature is really taking place inside through the majority of the evaporator coil. On the outdoor unit, the opposite. Even though I'm taking my reading outside and I'm going to have my line hooked up on the actual liquid line, it doesn't mean that's where saturation is taking place. When I get my pressure converted to a saturated temperature, it's happening in the middle, the majority of the condensing coil. So let's think about this when we did the water boiling. Anytime we have water boiling, whether it's let's say it's at the stove and it's at sea level, water is going to boil at 212 degrees. That water cannot change temperature until all of the vapor is gone. And it cannot condense from a vapor back to liquid until all of it is now a liquid. It has to fully exchange. Think about a glass of ice. You take ice water, you put ice in it, and if you get time to equalize, the temperature of that will stay the same. It will stay at 32 degrees until all of the ice is melted. We're going to talk more about this later. It's a very important concept. It's also a type of saturation. Once all of the ice melts, then the temperature can either drop lower or go higher. But as long as there's ice and liquid together, it cannot change in temperature. It has to all change. So evaporation, whatever evaporator coil temperature is, it's going to stay that temperature. In the example we had in the previous video, our evaporator temperature was at 52.5. So here, 52.5, 52.5, 52.5, 52.5, 52.5, 52.5, 52.5, 52.5. All of this will be the exact same temperature. The difference is here we have a whole lot more liquid, half and half, and now my liquid is almost completely gone. Over here we have the opposite. My refrigerant over here is boiling at, or condensing at 96.2. So here it's 96.2, 96.2, 96.2, 96.2, 96.2, 96.2, 96.2. It's going to be the exact same temperature throughout saturation until all of the liquid and vapor is either gone. Here, all of my vapor turns into a liquid or all of my liquid turns back to vapor. As long as there's both together, it's going to be at saturation. Now, whether we're talking about analog gauge sets, or we're going to go into digital gauge sets, or we're going to go into our fancy app, it's still that saturation is probably the most important term. It's the most awesome term for HVAC because one word means all of this really cool things. You can go and look at the book definition. It really goes even deeper, hopefully have some more understanding if you're struggling with saturation, but I need you to memorize those things. As I'm talking about saturation, replace those words with whichever word makes sense and it helps you to understand. So we call these temperature and pressure charts, but it's also called a saturated temperature pressure chart. Temperature pressure chart, T&P, saturated temperature, saturated pressure. These charts are essential in what we do, or at least as hand charts for passing the test, but the idea behind pressure converts to temperature, saturation, essential. We must know our saturated temperature. Very, very important. Write that one down. Rewatch the video if you need to 100 times. Put these notes in, put it on a flashcard, reference it, tattoo it in your brain.